All right, guys. So let's consider this other question on the board. Still on this charge, it says a pipe 450 millimeter in diameter is branched into two pipes 2 and 3 of diameters 300 millimeter and 200 millimeter respectively, as shown. If the average velocity in the 450 millimeter diameter pipe is 3 meters per second. Question says find one discharge through the 450 millimeter diameter pipe. Two, velocity in the 200 millimeter diameter pipe if the average velocity in the 300 millimeter pipe is 2.5 meters per second. Okay, so the information has already been displayed on the board. We have a single pipe 1, which is now branched into two pipes. This is 2 and this is 3. And the first pipe is of diameter 450 millimeter, moving with a speed. The flow in this pipe is actually moving with a speed of 3 meters per second. The second pipe is of diameter 300 millimeter. The flow in this pipe is moving with a speed V2 equals 2.5 meters per second. And then we'll have the final pipe, which is pipe 3, and of course the diameter is 200 millimeters and the speed is unknown. We are asked to find the speed of the flow in that pipe 3. Okay, so let's pick out our parameters. First, we are giving the first diameter, okay, through this the first pipe. So inlet diameter or D1 is given as 450 millimeter. That's 450 millimeter. We convert this to meters simply. 450 by 10 to the power of minus 3. This now implies that D1 is equal to 0.45 in meters. Okay. Next is to convert D2. D2 was given simply as 300 millimeter. So we have 300 millimeter, which is equal to 300 by 10 to the power of minus 3. And this simply gives us 0.3 in meters. Finally, D3 was given as 200 millimeter, which is equal to 200 by 10 to the power of minus 3, and this will give us 0.2 in meters. Now, the first question says calculate the discharge in the 450 millimeter diameter pipe, which is the first discharge here. Okay, and we know that discharge in this pipe Q1 is simply equal to area 1 times velocity of the pipe, velocity of flow in the pipe V1. So all we need to do is to obtain A1, V1 is given to us already, and then complete the discharge. Okay, so A1, that's area at section 1, area of pipe 1. Okay, A1 is equal to pi diameter 1 all squared divides by 4. So this simply implies that A1 is equal to pi is a constant value 3.142 multiplied diameter of that section give us 0.45 all squared divides by 4, and this is equal to, so we compute 3.142 multiply 0.45 squared. That gives us 0.636255 divides by 4. So this simply implies that area 1 is equal to 0.159 meter squared. So this becomes the area of pipe 1. Therefore, discharge through that pipe, discharge Q1 is now equal to, we said A1 times, okay, A1 times V1, A1 multiplied by velocity 1. This simply means that Q1 is equal to A1 gave us 0.159 multiplies V1 was given in the question as 3 meters per second. That's speed of flow through that pipe, multiplied by 3. This simply gives us 0.477 meter cube per second. Therefore, discharge through that pipe is 0.477 meter cube per second. Okay, so next question says we should find the speed of flow or velocity in the 200 millimeter pipe, which is pipe 3. We have to find V3. Okay, but before we do this, we have to employ the continuity equation. So take note now from continuity equation. Okay, it was this pipe that branched into this pipe. So discharge in this pipe is Q1, discharge through this pipe is Q2, and discharge through this pipe is Q3. And not forgetting, it was Q1 that vetted these two discharges. So this simply means that the continuity equation in this case now becomes Q1 is equal to Q2 plus Q3. Simply the sum of the discharges at pipe 2 and pipe 3 becomes equal to what? Discharge of pipe 1. So this becomes the continuity equation what? For this given condition. So if this pipe or had this pipe been branched up to 3 places, it has to be that Q1 equals Q2 plus Q3 plus Q4 and so on. Since it is this same pipe that is supplying the flow rate through what these two other pipes. So therefore, each discharge is equal to the sum of discharges between these two. So we know Q1. All we need to do now is find Q2, and of course, we have to obtain Q2. Q2 is also given as, which is discharge at pipe 2, is simply the area of pipe 2 times velocity of pipe 2. Pipe 2 has its own velocity as 2.5 meters squared. With the diameter, we can also obtain the area of pipe 2, and that makes it easier for us to be able to calculate the discharge through that given pipe. Let's do that over here and see. All right, so discharge in pipe 2, Q2 is simply A2 times V2. So let's obtain the area at portion 2. Area of 2, A2 is equal to pi times diameter at section 2 all squared divided by 4. Okay, A2 is equal to pi is constant, 3.142 multiplies diameter of that pipe. Diameter of pipe 2 was given as 0.3. So simply multiply by 0.3 all squared divide by 4. So we have here 3.142 multiplied 0.3 squared. That gives us 0.28278 divided by 4. So this simply implies that area of portion 2 is now equal to 0.28278 divided by 4. That gives us 0.07065 in meter squared. So we have this to be the area of portion 2. Next is to find the discharge now. Therefore, discharge at portion 2, Q2, is now equal to A2, which is 0.07065 multiplied by the velocity at portion 2, and velocity of the pipe at section 2 was given as 2.5 meter per second. So simply multiply by 2.5. This implies now that discharge at section 2 is now equal to 0.07065 multiplies 2.5. That gives us 0.177 meter cube per second. So we obtain discharge at portion 2. We have to now employ the continuity equation and find discharge at portion 3. That will help us to obtain the velocity at that portion. Okay. Let me wipe here. Alright, so from the continuity equation, we obtain that Q1 equals Q2 plus Q3, and Q1 was given to us as 0.477. We obtain this 0.477, and that's equal to, of course, Q2 now found. We obtain Q2 as 0.177, so that's equal to 0.177 plus Q3. Okay, so all we need to do now is make Q3 subject, that's discharge at pipe 3. Therefore, the flow rate in pipe 3 is simply equal to send 0.177 over here positive sign cross and equal to sign becomes negative. So it becomes 0.477 minus 0.177. This simply implies that discharge through pipe 3 is equal to 0.3 meter cube per second. And of course, if we know the discharge through that pipe, we can simply recall that discharge through the pipe Q3 is simply equal to area of pipe 3 multiplied by velocity of pipe 3. So we are asked to find velocity of that pipe. This simply implies that the velocity of the pipe or flow, velocity of the flow at pipe 3 it will now become discharge at pipe 3 Q3 all over area at pipe 3. So we need to now obtain the area of pipe 3. Area of pipe 3 is simply pi over 4 diameter of pipe 3 all squared. This is now equal to pi is constant. You have 3.142 multiplied by diameter of pipe 3. We obtain that D3 is 0.2 meters. Okay, this becomes 0.2 all squared divided by 4. Area of pipe 3 is now equal to, so we compute 3.142 multiplied 0.2 all squared. That gives us 0.12568 divided by 4. So this simply implies that the area of the pipe in portion 3 becomes 0.12568 divided by 4. That gives us 0.03142 in meter squared. So this becomes the area of the pipe at section 3. So if you've obtained this area, next is to compute the velocity of that portion. V3 is equal to Q3 all over A3. Therefore, velocity at point 3 or pipe 3 is simply equal to Q3, which is discharge at state 3, which is 0.3 divided by area of portion 3, which give us 0.03142. 0.03142. So this simply implies that velocity of that portion V3 is now equal to 0.3 divided 0.03142. That will simply give us 9.55 meters per second. So this becomes the velocity of the flow in pipe 3. Okay, so if you take a look at these speeds and their discharges, notice that the higher the diameter of the pipe, the smaller the speed. For instance, the first pipe has 450 millimeter diameter, which is the highest diameter in of all the pipes, and its speed was given as 3 meters per second. The next pipe was given as, which is the second pipe, 300 millimeter diameter, but look at the speed, 2.5 meter per second. And look at the pipe that has the smaller diameter, 200 millimeter diameter. Take a look at the speed, 9.5 meter per second, approximately 10. So the higher the diameter, the smaller the speed, and the smaller the diameter, the higher the speed. That is just it on discharges. All right, guys. I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you're new to the channel, please do well to subscribe to the channel, share this channel to your friends. Of course, tell them great and amazing things are happening here. Okay, for more subscribers. I will see you in the next video with more and more wonderful questions on discharges and flow rates. Thanks, guys, and cheers.